The world of agriculture is undergoing a profound transformation. Are we on the verge of a new green revolution? With global food demands increasing, how can technology revolutionize the way we produce food while safeguarding the planet? The answer lies in cutting-edge innovations that are reshaping agriculture as we know it. Join us as we explore 7 groundbreaking technologies that are powering the next wave of the green revolution. Together, let's dive into how these advances are leading us toward a more sustainable future. Stay tuned. This is a journey you won't want to miss. Precision farming, data-driven agriculture. Precision farming has transformed traditional agriculture by integrating advanced technology to optimize crop production and reduce environmental impact. This modern approach utilizes tools like GPS, drones, and sensors to gather real-time data on soil conditions, weather, and crop health. By analyzing this data, farmers can make precise decisions on planting, irrigation, and fertilization, ensuring that each area of the field receives the appropriate treatment. This results in higher yields, better resource management, and a reduced ecological footprint. A key advantage of precision farming is its ability to minimize water and chemical waste. Through the use of moisture sensors and automated irrigation systems, plants receive the exact amount of water they need, preventing both over- and underwatering. This method conserves water and reduces runoff from excessive irrigation. Additionally, variable rate technology, or VRT, enables precise application of fertilizers and pesticides, applying only the required amount based on crop needs. This minimizes environmental pollution and lowers costs for farmers. Drones and satellite imaging play a crucial role in precision farming, allowing farmers to monitor large areas of land efficiently. These tools capture high-resolution images that help detect issues like pest infestations, nutrient deficiencies, and water stress. With this detailed insight, farmers can address problems early, making interventions more timely and effective. The use of drones reduces the need for manual inspections, saving time and labor while improving overall farm management. As global food demand rises and climate change challenges agriculture, precision farming offers a vital solution. By leveraging data and technology, farmers can produce more food with fewer resources, supporting food security and environmental sustainability. As these technologies become more accessible, precision farming is poised to become a foundational practice in modern agriculture, meeting the demands of a growing population while preserving the planet's ecological balance. Vertical farming revolutionizing urban agriculture. Vertical farming is transforming food production by using vertically stacked layers to grow crops in controlled environments. This method allows year-round cultivation, often in urban areas where space is limited and traditional farming is impractical. With artificial lighting, climate control, and hydroponic or aeroponic systems, vertical farming offers a sustainable solution to the growing challenge of feeding a rising urban population without being affected by seasonal or weather conditions. One of the major benefits of vertical farming is its resource efficiency. Compared to traditional agriculture, vertical farming uses up to 95% less water by recycling it in a closed-loop system, which minimizes waste. Additionally, since these farms are often located near urban centers, the need for long-distance transportation is significantly reduced. This not only cuts fuel consumption and carbon emissions, but also ensures fresher, nutrient-rich food reaches consumers faster, improving both quality and shelf life. Vertical farming is also well suited for areas that lack suitable land for traditional farming. Cities like Singapore and New York, where space is scarce, have adopted vertical farming to boost food production. These farms can be set up in unused warehouses, shipping containers, or even skyscrapers, maximizing space in crowded areas. By growing food locally, vertical farming reduces dependence on global supply chains, making it more resilient to disruptions caused by extreme weather, trade issues, or pandemics. Beyond food security, vertical farming addresses key environmental concerns. Traditional farming is often linked to deforestation, soil degradation, and biodiversity loss. In contrast, vertical farming requires no arable land, reducing pressure on ecosystems. It also minimizes the use of pesticides and herbicides, cutting chemical runoff into water bodies. As vertical farming technology advances, it holds the potential to reshape global agriculture, creating a more sustainable, resilient food system for future generations. Gene editing, a new era of crop improvement. Gene editing, especially through CRISPR technology, is transforming agriculture by enabling the rapid development of more resilient, nutritious, and sustainable crops. Unlike traditional breeding, which can take years to achieve desired traits, gene editing allows scientists to make precise changes in plant DNA much faster. This innovation is creating crops that can better withstand environmental stresses such as drought, pests, and diseases, while also boosting yields and nutritional value. As global population grows and climate challenges intensify, gene editing holds great promise for improving food security. One critical application of gene editing is developing crops that can thrive in tough environmental conditions. For example, CRISPR is being used to produce drought-resistant varieties of corn and rice, which can grow in regions affected by climate change. Gene editing also enhances heat and salt tolerance in crops, making it possible to farm in areas previously unsuitable for agriculture. These developments are essential for regions with water scarcity or poor soil, where traditional crops struggle to survive. Beyond environmental resilience, gene editing is improving the nutritional content of food. Scientists have developed crops like iron-enriched rice and vitamin A-fortified cassava, which address nutrient deficiencies in many developing countries. These bio-fortified crops could help reduce malnutrition and reliance on supplements in areas where key nutrients are scarce. By making staple foods healthier, gene editing has the potential to improve global nutrition and public health. However, gene editing faces challenges such as regulatory hurdles and public concerns about genetically modified organisms, or GMOs. While gene-edited crops differ from GMOs as they don't involve foreign genes, public perception remains a barrier. Scientists and policymakers need to create clear regulations and educate the public on the safety and benefits of gene-edited crops. As these issues are resolved, gene editing is likely to become a central tool in modern agriculture, helping to sustainably increase food production and enhance nutrition worldwide. Robotics in farming, automating agriculture. The rise of robotics in farming is transforming agriculture by automating labor-intensive tasks and boosting efficiency. From autonomous tractors to fruit-picking robots, these technologies are revolutionizing how crops are grown, managed, and harvested. As agriculture faces challenges like labor shortages, rising food demand, and environmental pressures, robotics offers solutions that improve productivity and resource conservation. These innovations are paving the way for a future where machines work alongside farmers, elevating efficiency. A key application is autonomous machinery. Self-driving tractors equipped with GPS and AI can plow, plant, and harvest with minimal human input. These machines work 24/7, executing tasks with precision and speed beyond human capability. Autonomous robots also handle repetitive tasks like weeding and seeding, reducing labor needs and increasing accuracy. This precision helps farmers cut costs, optimize resources, and minimize environmental impact. Robotics is also changing how crops are harvested, especially delicate fruits. Traditionally, fruit picking required large labor forces, but robots with advanced vision systems can detect and pick fruits like strawberries and apples at peak ripeness, reducing waste and speeding up harvests. Beyond the fields, robotics is enhancing processes like sorting, packaging, and livestock management. Robotic milking systems allow cows to be milked on demand, improving efficiency and animal welfare. Robots can also monitor livestock health, detecting early signs of illness. As these technologies evolve, they help farmers adopt more sustainable, humane practices, contributing to a greener future for agriculture. Green ammonia revolutionizing fertilizer production. Ammonia is vital for fertilizers, supporting nearly half of the world's food production by enhancing crop yields. However, traditional ammonia production via the Haber-Bosch process is energy-intensive, consuming around 2% of global energy and contributing approximately 1.8% of CO2 emissions. The rise of green ammonia, produced using renewable energy, offers a more sustainable and eco-friendly alternative. This innovation not only lowers greenhouse gas emissions, but also addresses the growing food demand more responsibly. Green ammonia is made by combining nitrogen from the air with hydrogen produced through electrolysis powered by renewable sources like wind and solar. Unlike traditional fossil fuel-based methods, green ammonia generates zero carbon emissions. This is a crucial development in decarbonizing agriculture, as fertilizers are key to global food production. By transitioning to green ammonia, the agricultural sector can significantly reduce its carbon footprint, supporting global climate goals. In addition to its use in fertilizers, green ammonia holds promise as a clean energy source. It can be stored and transported more easily than hydrogen and used as fuel, particularly in industries like shipping that are seeking alternatives to carbon-heavy fuels. Ammonia-powered ships could reduce emissions in the maritime industry, contributing to broader efforts to decarbonize global industries. Its dual role as a fertilizer and clean fuel makes green ammonia a critical tool in the shift toward a low-carbon economy. Countries and companies are investing in green ammonia with pilot projects in Australia, Europe, and Japan. As renewable energy becomes more accessible and cost-efficient, green ammonia production is expected to scale up, making it a viable alternative to traditional ammonia. This marks a major step toward agricultural sustainability and a cleaner energy future, where food production and energy consumption are more environmentally friendly. Connected technology, the Internet of Things, IoT, in agriculture. The Internet of Things, IoT, is revolutionizing agriculture by connecting devices, sensors, and machinery to create smart farming ecosystems. By collecting real-time data and analyzing it on cloud platforms, IoT allows farmers to monitor, automate, and optimize their operations more effectively. From soil sensors to drones, these technologies enable data-driven decisions, improving productivity and reducing resource waste. As IoT continues to integrate into farming, it is reshaping agriculture for a more efficient future. A key benefit of IoT in agriculture is precision irrigation management. Soil sensors measure moisture, temperature, and nutrients, providing farmers with real-time data on soil conditions. This enables accurate water management, ensuring crops get the right hydration. Automated irrigation systems can activate only when necessary, conserving water and reducing costs, especially crucial in drought-prone regions. IoT also enhances pest control and crop health monitoring. Drones equipped with cameras and sensors can survey large areas, detecting early signs of disease, pests, or nutrient deficiencies. This allows farmers to address issues promptly, applying fertilizers or pesticides only where needed, minimizing chemical use and reducing environmental impact. Smart pest monitoring systems also enable targeted interventions, improving sustainability. As 5G networks expand, IoT will become even more advanced, allowing seamless communication between devices and deeper data analysis. Farmers will be able to remotely control key aspects of their farms via smartphone apps, from irrigation to livestock monitoring. Predictive analytics powered by machine learning will help farmers forecast crop yields, optimize planting schedules, and anticipate challenges like extreme weather. With IoT, agriculture is becoming smarter, more sustainable, and better equipped to feed a growing global population. AI and robotics, shaping the future of agriculture. Artificial intelligence, AI, and robotics are revolutionizing agriculture, transforming how crops are grown, managed, and harvested. These technologies address key challenges like labor shortages and the need for higher food production amidst climate change. By integrating AI-driven data analysis and autonomous robots, farming is becoming more efficient, precise, and sustainable. These innovations are laying the groundwork for the future of agriculture, where technology plays a crucial role in feeding the world's growing population. AI's greatest impact in agriculture is its ability to optimize farming decisions. AI-powered systems analyze data such as soil conditions, weather patterns, and market trends, helping farmers make smarter choices about planting, watering, and harvesting. Machine learning algorithms can also predict pest outbreaks and diseases, enabling proactive measures that reduce pesticide use and protect crops. Through predictive analytics, AI increases crop yields while minimizing waste and conserving resources. Robotics automates many time-consuming tasks. Autonomous tractors can plow fields with accuracy, while robotic harvesters pick delicate fruits and vegetables without damage. These machines work faster and more efficiently than human labor, reducing the need for large workforces. Robots are also being developed for tasks like weeding, seeding, and milking cows, allowing farmers to save time, cut costs, and improve productivity while ensuring consistent quality. In plant breeding and greenhouse management, AI models accelerate the development of climate-resilient crops by identifying desirable genetic traits. AI-driven greenhouse systems automatically regulate temperature, humidity, and lighting to create optimal growing conditions. These advancements promote sustainability by reducing water, energy, and chemical use. As AI and robotics evolve, they are set to reshape agriculture, making it more productive and sustainable for the future. As we wrap up, it's clear that the future of agriculture lies in the innovative technologies driving the green revolution. From precision farming to AI and robotics, these advancements are reshaping how we grow food sustainably in a rapidly changing world. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the world's wonders with us. Have you ever wondered what lies beyond the point of no return, where even light cannot escape? Black holes, the enigmatic monsters of the cosmos, have fascinated scientists and dreamers alike for decades. From their mysterious formation to their immense gravitational power, black holes challenge our understanding of space and time. Join us as we dive into the incredible world of black holes and uncover their secrets, exploring the science, the wonder, and the unknown. The formation of black holes, the birth of a cosmic giant. Black holes form from the remnants of massive stars that have reached the end of their lives. As a star burns through its nuclear fuel, it maintains a delicate balance between the outward pressure of nuclear fusion and the inward pull of gravity. When the fuel is depleted, gravity wins the battle, causing the star to collapse under its own weight. For stars much larger than our Sun, this collapse leads to the formation of a singularity, a point of infinite density where the laws of physics as we know them break down. Surrounding this singularity is the event horizon, the boundary beyond which nothing can escape. The gravitational pull here is so intense that not even light, the fastest thing in the universe, can escape its grasp. Not all black holes are created equal. Stellar mass black holes are born from the death of stars, while supermassive black holes, millions to billions of times the mass of our Sun, reside at the centers of galaxies. These colossal entities likely formed from the merger of smaller black holes and the accretion of vast amounts of matter over time. Intermediate mass black holes, a middle ground between stellar mass and supermassive, have been harder to find, but their discovery has opened new avenues for understanding black hole evolution. Their formation remains one of the great mysteries in astrophysics, providing a link between the small and the colossal. The creation of black holes is a process that illustrates the immense power and complexity of the universe. From the remnants of dying stars to the titanic forces shaping galaxies, black holes remind us that even destruction can lead to profound new beginnings in the cosmos. The anatomy of a black hole, beyond the event horizon. A black hole is more than just an abyss. It is a complex structure with distinct parts that play a crucial role in its behavior and influence. At its heart lies the singularity, the point of infinite density and zero volume where gravity is so intense that it warps space and time to extremes. Surrounding the singularity is the event horizon, often referred to as the point of no return. Once an object crosses this boundary, escape becomes impossible. The event horizon is not a physical surface, but rather a mathematical boundary defined by the black hole's immense gravitational pull. Outside the event horizon, many black holes are surrounded by an accretion disk, a swirling mass of gas, dust, and debris drawn in by the black hole's gravity. As this matter spirals inward, it heats up to millions of degrees, emitting intense radiation that can be detected by telescopes on Earth. In some cases, black holes produce powerful jets of high-energy particles that shoot out from their poles at nearly the speed of light. These jets are powered by the intense magnetic fields generated by the accretion disk and can extend for thousands of light years, influencing the formation of stars and galaxies. Understanding the anatomy of a black hole reveals the intricate processes at work in these celestial phenomena. They are not simply voids, but dynamic and influential objects that play a pivotal role in shaping the universe around them. How black holes warp space and time. Black holes are more than gravitational traps. They are cosmic engines that distort the fabric of space and time. According to Einstein's general theory of relativity, massive objects like black holes curve space-time, much like a heavy ball placed on a stretched rubber sheet. As a result, time near a black hole slows down relative to an observer far away. This phenomenon, known as time dilation, means that a clock near the event horizon ticks more slowly than one in a distant region of space. If you were to observe an astronaut falling into a black hole, Their movements would appear to slow down as they approached the event horizon, eventually freezing in place. The intense warping of space-time also affects light. Black holes can bend light paths, creating a phenomenon called gravitational lensing. This effect allows astronomers to see objects hidden behind massive celestial bodies, as light from distant stars and galaxies is bent around the black hole. At the event horizon, space-time becomes so warped that all paths lead inward. Once something crosses this boundary, it is destined to fall into the singularity. This extreme distortion of space-time challenges our understanding of the universe and raises questions about the nature of reality itself. By studying how black holes warp space and time, scientists gain insights into the fundamental laws of physics and the relationship between gravity, matter, and energy. Black holes are laboratories for testing the limits of our theories and exploring the universe's deepest mysteries. Black holes and the cosmic web. Black holes are not isolated entities. They are deeply connected to the large-scale structure of the universe. They play a central role in the formation and evolution of galaxies, often acting as the anchors around which galaxies grow. Supermassive black holes, located at the centers of galaxies, influence the motion of stars and gas in their vicinity. Their immense gravitational pull binds galaxies together, while the energy released from accretion disks and jets can regulate star formation by heating and dispersing surrounding gas. Galactic collisions and mergers often lead to the merging of black holes, creating even larger supermassive black holes. These events release powerful gravitational waves, ripples in space-time that can be detected by instruments like LIGO and Virgo. The relationship between black holes and the cosmic web extends beyond galaxies. The jets from supermassive black holes can shape the intergalactic medium, distributing energy and influencing the formation of galaxy clusters. Black holes are key players in the intricate interplay of forces that define the universe's structure. By understanding the connection between black holes and the cosmic web, astronomers piece together the story of how galaxies and the universe itself have evolved over billions of years. The Event Horizon Telescope. The Event Horizon Telescope, or EHT, represents a groundbreaking effort to capture images of black holes, allowing humanity to glimpse the unseeable. Using a global network of radio telescopes synchronized to act as a single Earth-sized instrument, the EHT captured the first-ever image of a black hole in 2019. This historic achievement revealed the shadow of the black hole at the center of galaxy M87, surrounded by a glowing ring of hot, spiraling matter. The image was more than just a visual spectacle. It confirmed the existence of event horizons and matched predictions made by Einstein's theory of general relativity. The glowing ring represents light bending around the black hole, while the dark shadow marks the region where light cannot escape. This discovery offered direct evidence of how black holes warp spacetime and manipulate matter. The EHT's success was a culmination of years of collaboration among hundreds of scientists and engineers. Data collected from observatories worldwide was combined using a technique called very long baseline interferometry, enabling the extraordinary resolution necessary to image a black hole's shadow. Building on this achievement, the EHT is now targeting other black holes, including the one at the center of our galaxy, Sagittarius A*. These efforts promise to reveal even more about the enigmatic nature of black holes and their environments, providing a window into phenomena that were once purely theoretical. The Event Horizon Telescope has opened a new frontier in astronomy, proving that humanity can tackle the most daunting challenges in exploring the cosmos. It is a testament to the power of global collaboration and the unyielding human desire to uncover the universe's deepest mysteries. The power of gravitational waves. Listening to cosmic collisions. Gravitational waves, ripples in the fabric of spacetime, are one of the most exciting tools for studying black holes. First predicted by Einstein's general theory of relativity, these waves are produced by cataclysmic events such as the collision of black holes. In 2015, the LIGO Observatory detected gravitational waves for the first time, marking a new era in astrophysics. When two black holes spiral toward each other and merge, they release an immense amount of energy in the form of gravitational waves. These ripples travel across the universe, carrying information about the masses, spins, and distances of the merging black holes. Observatories like LIGO and Virgo capture these signals, allowing scientists to study cosmic events that would otherwise be invisible. Gravitational wave astronomy has led to several remarkable discoveries. It has revealed the existence of binary black holes, confirmed theories about their formation, and provided insights into the nature of space-time itself. Each detection expands our understanding of the violent and dynamic processes that shape the universe. The study of gravitational waves has also opened the door to exploring the unknown. By observing waves from black hole collisions, scientists test the limits of general relativity and search for evidence of phenomena like primordial black holes, which may have formed shortly after the Big Bang. Gravitational waves are more than a breakthrough. They are a new way of experiencing the universe. They allow us to listen to the cosmos, unlocking secrets that were once hidden in silence and enriching our understanding of black holes and their dramatic lives. Black holes and the nature of information. Black holes present one of the most perplexing paradoxes in modern physics, the information paradox. According to quantum mechanics, information about the physical state of matter should never be destroyed. However, when matter falls into a black hole, it appears to vanish beyond the event horizon, seemingly erasing all traces of its properties. This paradox challenges the foundations of physics. Stephen Hawking's groundbreaking work on black hole radiation, known as Hawking radiation, suggests that black holes emit energy and can eventually evaporate over immense timescales. Yet this radiation seems to carry no information about the matter that formed the black hole, intensifying the puzzle. Physicists have proposed various solutions to the paradox. One theory suggests that information is encoded on the event horizon itself, much like a hologram. This concept, known as the holographic principle, implies that the universe's three-dimensional nature may be a projection of information stored on a two-dimensional surface. Another idea is that information may escape through subtle quantum effects during the emission of Hawking radiation. These theories are still being tested and debated, but they represent profound implications for our understanding of quantum mechanics, gravity, and the nature of reality. The information paradox demonstrates that black holes are not just astronomical objects, but philosophical and scientific challenges. They force us to reconsider fundamental assumptions about the universe, bridging the worlds of quantum mechanics and general relativity in a quest for a unified theory of physics. The ultimate fate of black holes. Black holes are not eternal. Over incredibly long timescales, they lose energy through a process known as Hawking radiation. This phenomenon occurs because of quantum effects near the event horizon, where particle-antiparticle pairs form and one falls into the black hole while the other escapes, carrying away energy. As black holes emit radiation, they slowly lose mass, shrinking over billions or even trillions of years. Eventually, a black hole will evaporate entirely, releasing a final burst of energy before disappearing. This process, though theoretical, has profound implications for the fate of black holes in the universe. In a far distant future known as the heat death of the universe, when stars have burned out and galaxies have dispersed, black holes may be the last remaining objects. Their slow evaporation will mark the final stages of cosmic evolution, leaving a cold, empty expanse. The study of black hole evaporation also sheds light on the interplay between quantum mechanics and gravity. Understanding Hawking radiation could lead to new breakthroughs in unifying these two fundamental forces, offering a glimpse into the underlying fabric of the universe. Black holes, born from the fiery deaths of stars, ultimately fade into obscurity. Their life cycle, from colossal gravitational monsters to evaporating whispers, symbolizes the incredible transformations that define the universe's story. They remind us that even the most powerful phenomena are not immune to the passage of time. The mysteries of black holes inspire awe and curiosity, challenging us to expand our understanding of the universe. From their formation to their profound influence on space and time, black holes are among the most fascinating phenomena in existence. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep uncovering the universe's secrets with us.
Have you ever wondered what secrets lie beyond our Milky Way? The Andromeda Galaxy, our nearest galactic neighbor, is a cosmic marvel packed with mysteries and mind-blowing facts. Did you know it's on a collision course with the Milky Way, or that it contains over 1 trillion stars? Join us on this captivating journey as we unravel 10 fascinating facts about the Andromeda Galaxy and explore the universe like never before. The largest galaxy in our local group. The Andromeda Galaxy isn't just a stunning celestial object, it's also the largest galaxy in the local group, a cosmic neighborhood that includes the Milky Way and around 54 smaller galaxies. Stretching approximately 220,000 light-years in diameter, Andromeda is about twice the size of the Milky Way. Its sheer scale makes it a crucial subject for scientists studying galactic formation and evolution. Despite its massive size, Andromeda's structure is relatively familiar. It's a spiral galaxy with a bright central bulge and magnificent arms that sweep outward, filled with stars, gas, and dust. These arms are a breathtaking sight when captured in high-resolution images, revealing vibrant regions of star formation. Andromeda's immense size also means it has a significant gravitational influence. It has several satellite galaxies orbiting it, much like the Milky Way has the Magellanic Clouds. These smaller galaxies offer researchers a window into the dynamics of galactic interactions and mergers, processes that shape the cosmos over billions of years. For stargazers, Andromeda is an awe-inspiring sight. Under clear, dark skies, you can even spot it with the naked eye. Located 2.5 million light-years away, this majestic galaxy reminds us of the vastness and beauty of the universe, sparking curiosity and wonder in all who observe it. Home to over 1 trillion stars. One of the most astonishing facts about the Andromeda Galaxy is its staggering number of stars. With over 1 trillion stars, it outshines our Milky Way, which has around 200 to 400 billion stars. This enormous population makes Andromeda a treasure trove for astronomers searching for clues about the life cycles of stars and the potential for planets in distant galaxies. Within Andromeda, you'll find stars of all types, from ancient red giants to young, hot blue stars. Its dense star clusters like NGC 206 are particularly fascinating, showcasing regions teeming with newly formed stars. These clusters are prime targets for telescopes and provide a glimpse into the galaxy's stellar diversity. Andromeda's stars are distributed across its expansive disk and central bulge. Its nucleus is especially intriguing, with a supermassive black hole surrounded by a dense cluster of stars. This setup is similar to what we see in the Milky Way, offering a chance to compare and contrast galactic centers. With such a vast number of stars, the possibilities for planetary systems and perhaps even extraterrestrial life are tantalizing. While we may be light-years away from uncovering these secrets, Andromeda continues to inspire dreams of intergalactic exploration and discovery. Andromeda and the Milky Way are on a collision course. Perhaps the most dramatic fact about the Andromeda Galaxy is its eventual fate. It's on a direct collision course with the Milky Way. Traveling at a speed of about 110 kilometers per second, Andromeda will merge with our galaxy in roughly 4.5 billion years. This galactic dance is a vivid reminder of the ever-changing nature of the cosmos. When Andromeda and the Milky Way collide, it won't be a violent crash as one might imagine. Galaxies are mostly empty space, so stars and planets are unlikely to collide directly. Instead, the gravitational forces will reshape both galaxies, creating a new elliptical galaxy often referred to as Milkomeda. During this cosmic event, the night sky on Earth will transform dramatically. Andromeda will grow larger and brighter, dominating the heavens as the galaxies draw closer. The eventual merger will set off bursts of star formation as gas and dust clouds collide and compress, igniting new stars. While the collision sounds catastrophic, it's a natural part of galactic evolution. For astronomers, it's a thrilling opportunity to study these processes and gain insights into the life cycle of galaxies. For us, it's a humbling reminder of our place in an ever-evolving universe. A history of galactic cannibalism. The Andromeda Galaxy has a history as dramatic as its future. It's known for its role as a cosmic cannibal, having absorbed smaller galaxies over billions of years. This process, known as galactic cannibalism, has helped Andromeda grow to its current size and complexity. Evidence of this cosmic appetite comes from the faint streams of stars that extend outward from Andromeda's disk. These star streams are remnants of dwarf galaxies that were pulled in and torn apart by Andromeda's gravitational forces. Observations of these features have provided astronomers with a clearer picture of how galaxies grow through mergers. Andromeda's appetite isn't just limited to smaller galaxies. Its gravitational pull influences nearby systems, setting the stage for future interactions. This ability to dominate its local environment underscores its status as a powerful cosmic entity. The history of galactic cannibalism reminds us that galaxies are not static structures. They evolve and change, driven by the intricate ballet of gravity. Andromeda's story is a testament to the dynamic nature of the universe, where even the mightiest galaxies are shaped by the forces around them. A supermassive black hole at its core. At the heart of the Andromeda Galaxy lies a supermassive black hole, an enigmatic entity that exerts immense gravitational pull. Located in its nucleus, this black hole is estimated to be between 100 and 200 million times the mass of our Sun. It's surrounded by a dense cluster of stars, creating one of the most energetic regions in the galaxy. This black hole is not just a solitary entity. Evidence suggests Andromeda's core may harbor two black holes in a binary system, the remnants of a galactic merger billions of years ago. This discovery adds a layer of intrigue to Andromeda's history, offering clues about its tumultuous past. The influence of the supermassive black hole extends far beyond its immediate vicinity. It shapes the orbits of stars in the central bulge, creating a dynamic and chaotic environment. The study of Andromeda's core provides a unique opportunity to understand how these powerful objects influence galaxy formation and evolution. For astronomers, the supermassive black hole in Andromeda is like a cosmic laboratory. Observing its activity helps scientists uncover the secrets of black hole growth, galactic interactions, and the role of gravity in shaping the universe. It's a stark reminder of the power and mystery hidden within galaxies. Andromeda is blue-shifted. Unlike most galaxies, which are red-shifted as they move away from us, Andromeda is blue-shifted. This means it's moving toward the Milky Way, and its light appears compressed to shorter wavelengths. This unique characteristic is a direct result of the impending collision between the two galaxies. The blue shift is a rare phenomenon in astronomy, as the universe is generally expanding. Andromeda's motion defies this trend because the gravitational pull between it and the Milky Way is stronger than the universe's expansion in our local group of galaxies. This unusual movement offers astronomers a real-time view of galactic dynamics on a grand scale. Studying Andromeda's blue shift allows scientists to measure its speed and trajectory with remarkable precision. It also provides a glimpse into the processes that govern galaxy interactions, helping researchers understand the intricate gravitational ballet that defines the cosmos. For us, the blue-shifted light is a cosmic signal of Andromeda's approach. It's a reminder that even in the vastness of space, galaxies are in constant motion, influenced by unseen forces that connect them across unimaginable distances. A rich history of star formation. The Andromeda Galaxy boasts an extraordinary history of star formation, spanning billions of years. Its expansive disk is filled with regions where stars are born, fueled by vast reservoirs of gas and dust. These stellar nurseries create breathtaking phenomena that can be observed with advanced telescopes. One of the most active areas in Andromeda is its spiral arms, where star-forming regions shine brightly. These arms are dotted with hot young stars that illuminate their surroundings, creating stunning visual contrasts against the dark cosmic backdrop. Andromeda's history isn't just about new stars, it's also a story of cycles and change. Some regions show evidence of older stars that have exhausted their fuel, leaving behind white dwarfs, neutron stars, and even black holes. This diversity offers a comprehensive view of stellar evolution within a single galaxy. The study of star formation in Andromeda provides valuable insights into our own galaxy's past. By comparing the two, astronomers can piece together the puzzle of how galaxies evolve over time, creating the complex and beautiful structures we see today. A spiral with a halo. The Andromeda Galaxy isn't just its spiral disk, it's surrounded by an enormous halo of gas and stars that extends far beyond its visible edges. This halo is so vast that it spans over 1 million light-years, making it larger than the galaxy itself. This halo is composed of hot gas, old stars, and remnants of galaxies Andromeda has absorbed. It acts as a cosmic shield, interacting with Andromeda's surroundings and playing a crucial role in its evolution. Observing this halo provides insights into how galaxies acquire and lose mass over time. The halo also contains globular clusters, dense groups of ancient stars that orbit the galaxy's core. These clusters are some of the oldest objects in the universe, dating back to the early days of galactic formation. Their presence offers a glimpse into the conditions that existed when the universe was young. For astronomers, the halo of Andromeda is like a cosmic time capsule. It holds clues about the galaxy's past interactions, its growth, and the forces that shaped it. It's a reminder that galaxies are not isolated entities but are deeply connected to the universe around them. Bright Cepheid variables in Andromeda. One of the most fascinating aspects of the Andromeda galaxy is its abundance of Cepheid variable stars. These stars are known for their consistent brightness fluctuations, which make them invaluable tools for measuring cosmic distances. The discovery of Cepheid variables in Andromeda was a groundbreaking moment in astronomy. In the 1920s, Edwin Hubble used these stars to calculate the distance to Andromeda, proving for the first time that it lay outside the Milky Way. This revelation transformed our understanding of the universe, showing that it was far larger and more complex than previously imagined. Today, Cepheid variables continue to play a vital role in astronomy. Their predictable patterns of light help scientists refine distance measurements and study the expansion of the universe. Andromeda's Cepheids remain a key resource for calibrating cosmic scales. These stars are more than just tools for astronomers. They're a testament to the power of observation and the ingenuity of scientists who unlock the universe's secrets. They remind us that even the smallest flickers of light can lead to the greatest discoveries. The Andromeda Galaxy's two cores. Andromeda's nucleus is a mystery that has fascinated astronomers for decades. Unlike most galaxies, it appears to have two distinct cores. These cores are likely the result of a galactic merger that took place billions of years ago, leaving behind a dynamic and complex central region. The two cores consist of densely packed stars orbiting a shared gravitational center. One core is thought to be the original nucleus of Andromeda, while the other is likely the remnant of a smaller galaxy that was absorbed during a merger. This unique structure offers a rare glimpse into the aftermath of galactic collisions. Studying these cores has revealed intriguing details about Andromeda's past. Their interactions show how galaxies grow and evolve through mergers, reshaping themselves over time. These findings also help scientists understand the role of central black holes in shaping galactic nuclei. For stargazers and scientists alike, Andromeda's double core is a captivating feature. It's a reminder that galaxies are constantly changing, shaped by the cosmic forces that govern the universe. It's a story of resilience and transformation on an intergalactic scale. That wraps up our journey through the Andromeda Galaxy, a breathtaking marvel of the cosmos filled with incredible secrets and discoveries. From its massive size to its dynamic future, Andromeda inspires wonder and curiosity. If you enjoyed this cosmic adventure, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated on our latest videos. Until next time, keep exploring the universe with us. What if right now, in another universe, you're living a completely different life? Maybe you're a famous actor, a billionaire, or even an astronaut exploring a distant planet. Sounds crazy, right? But what if science says it's possible? The idea of parallel universes isn't just science fiction, it's something real physicists are actually exploring. But here's the big question. If alternate realities exist, could we ever travel between them? Could déjà vu be a glitch between worlds? Stick around, because we're about to dive into one of the biggest mysteries of the universe, and you might never see reality the same way again. The multiverse concept. Have you ever stopped to think, what if there's another version of you, right now, living a completely different life? Maybe in some alternate reality you're a famous musician, a billionaire, or even an astronaut exploring Mars. Sounds crazy, right? But hold on. Science suggests that this idea might not be as far-fetched as it seems. The multiverse theory proposes that our universe is just one of many, an infinite number of realities where every possible version of your life plays out. In one universe, you might have taken that job offer you turned down. In another, you never even existed. It's like a cosmic choose-your-own-adventure book, but every choice actually happens in a separate universe. Why does this idea matter? Well, if alternate universes exist, it changes everything we know about reality, fate, and free will. What if our dreams, déjà vu moments, or gut feelings are actually glimpses of another version of ourselves living in a parallel world? What if those unexplained coincidences, meeting a stranger who feels oddly familiar, or predicting an event before it happens, aren't coincidences at all. The possibility of an alternate universe isn't just science fiction. Physicists, mathematicians, and even philosophers have spent years trying to crack this mystery. Could it be that we are just scratching the surface of something far bigger than we can comprehend? Buckle up, because the journey into the multiverse is about to get a lot deeper. Scientific theories of parallel universes. Okay, so let's get one thing straight. This isn't just wild imagination. There are actual scientific theories that hint at the existence of multiple universes, and they come from some of the brightest minds in physics. One of the biggest ideas? The many worlds interpretation. This comes straight from quantum mechanics, the branch of physics that deals with the tiny, bizarre world of particles. According to this theory, every time a decision is made, every single choice, no matter how small, the universe splits into multiple realities where every possible outcome actually happens. Right now, in some alternate universe, another version of you picked a different career, moved to another country, or even skipped watching this video. Then there's the cosmic inflation theory. Ever heard of the Big Bang? Scientists believe that during the very early moments of our universe, it expanded at an insane rate, like a balloon inflating super fast. This theory suggests that different parts of space might have inflated at different speeds, creating separate independent universes, each with its own laws of physics. That means somewhere out there could be a universe where gravity works differently, where light travels at a different speed, or where time itself doesn't even exist. And get this, some researchers even believe that black holes might be portals to other universes. When something falls into a black hole, it gets crushed into oblivion. Or does it? Some theories suggest that instead of being destroyed, that matter is actually transported to another universe entirely. So what does this all mean? If these theories hold up, then parallel universes might not just be possible, they might be inevitable. The real question is, will we ever find a way to travel between them? Implications of alternate realities. Now, here's where things get personal. If alternate universes really exist, then who are you? Are you just one version of yourself out of an infinite number of possibilities? Think about it. If there are multiple realities where different versions of you exist, does that mean your identity isn't as unique as you thought? Let's say you made a life-changing decision a few years ago. Maybe you quit your job, moved to a new city, or broke up with someone. According to the multiverse theory, in another universe, there's a version of you who made the opposite choice. That version of you might be living a completely different life right now. Maybe they're thriving, maybe they're struggling, but either way they exist. This also raises the question, how much of our lives are actually in our control? If every possible choice creates a new reality, then, technically, every version of your life is happening somewhere. Does that mean free will is just an illusion? Or does it mean that every decision, no matter how small, matters more than we ever realized? And here's something even weirder. What if we sometimes feel these alternate versions of ourselves? Have you ever experienced a moment where you knew something was going to happen before it did? Or felt an unexplainable connection to a place you've never been before? What if those are glimpses of another reality bleeding into our own? If alternate universes exist, then your entire sense of self might be way more complicated than you ever imagined. Maybe you're not just you, you're part of something much, much bigger. Cultural and philosophical perspectives. The idea of parallel universes isn't just a scientific curiosity, it's something that has fascinated humans for centuries. Across cultures, religions, and philosophies, there have always been stories about other versions of reality. Take Hinduism and Buddhism, for example. Both traditions talk about the idea of multiple worlds and different versions of existence. In some interpretations, karma doesn't just affect your next life. It could also play out across multiple realities at once. Could these ancient beliefs be an early glimpse into what science is now exploring? Then there's philosophy. Ever heard of the what-if paradox? It's the idea that every decision creates an alternate path. Some philosophers believe that every choice we make splits reality, which means infinite realities exist, each one shaped by a different version of your past decisions. Sound familiar? That's basically the many worlds interpretation, but through the lens of philosophy instead of physics. And of course, we see the idea of alternate realities everywhere in pop culture. From Marvel's Multiverse of Madness to Stranger Things, from Rick and Morty to Interstellar, the concept of multiple universes is a storytelling goldmine. Why? Because deep down we all wonder, what if my life had gone differently? But here's the real kicker. What if these stories aren't just fiction? What if we're drawn to these ideas because on some subconscious level we know there's truth to them? Maybe, just maybe, the reason we love stories about parallel universes is because our minds are already connected to them in ways we don't fully understand yet. Technological advances. Alright, let's get to the big question. Can we actually prove that alternate universes exist? Right now, we can't exactly hop into a spaceship and visit Earth 2, or shake hands with an alternate version of ourselves, but that doesn't mean scientists aren't trying. One of the most exciting areas of research is quantum computing. Unlike regular computers which use bits, quantum computers use qubits, which can exist in multiple states at once. Some physicists believe that this strange behavior hints at parallel worlds interacting with our own at the microscopic level. Could quantum computers one day help us access these other realities? Then there's the Large Hadron Collider, the massive particle accelerator beneath Switzerland. Some scientists speculate that high-energy particle collisions could create tiny, mini black holes, which might provide evidence of other dimensions or universes. In other words, we might be closer than we think to unlocking the secrets of the multiverse. And let's talk about dark matter, the mysterious invisible substance that makes up most of the universe but doesn't interact with light. Some scientists believe that dark matter could be leaking in from parallel universes. Imagine that. What if an entire hidden reality is right next to us, but we just don't have the tools to see it yet? The bottom line? We might be on the verge of one of the biggest discoveries in history. If alternate universes exist, science will find a way to prove it. And who knows? Maybe one day, we'll find a way to travel between them. The allure of the unknown. So after all of this, where does that leave us? Is there really another version of you out there living a different life? Maybe, maybe not. But here's the thing. The possibility alone changes everything. Think about it. If alternate universes exist, it means every choice you've ever made has played out somewhere. Every dream you've had, every risk you didn't take, every what-if moment, it all exists somewhere in the vast multiverse. And if that's true, then what does it say about the life you're living right now? What if we're more connected to these alternate realities than we realize? What if those strange moments, déjà vu, vivid dreams, unexplainable instincts, aren't just random, but glimpses of something bigger? What if the universe isn't just a place but a network of infinite possibilities, all playing out at the same time? One thing's for sure, the more we learn about the universe, the more mysterious it becomes. And whether or not we ever find proof of the multiverse, one thing is undeniable. The search for answers is what makes us human. Because in the end, we aren't just looking for other universes, we're looking to understand our own. The idea of alternate universes is mind-blowing, but what if it's more than just theory? What if every choice, every possibility is playing out somewhere right now? Science is getting closer to unlocking these secrets, so who knows what we'll discover next? If you enjoyed this deep dive into the unknown, make sure to subscribe to InnoVision Tech for more mind-expanding content. Hit that like button, drop a comment, and let's keep exploring the future together. See you in the next one.